Today we're going to go over some example problems that you'll see on your homework tonight. I kind of gave you the easy ones on the last homework assignment, so these get into a little more of the difficult ones. We're going to establish just a couple things on this stuff about like how we know whether it's going to be going to positive or negative infinity without graphing it. And those are kind of common sense topics, so that'll help. All right, so for this first one, it's 1 over x squared minus 4. And then it's as x approaches 2 from the right is part A. That's our first one. Now, I finished grading your quizzes, and a lot of you did not factor at all whenever we were doing stuff. In general, whenever you see an equation on the bottom, or what's called a rational function, you're going to want to factor that out. The other thing that a lot of you did was factored incorrectly. So this is 1 over x minus 2 times x plus 2. Now when I see that, it's going to be easier to recognize what happens as I'm coming from the right. When I come from the right, like say 2.1. 2.1 minus 2 is 0.1. 2.1 plus 2 is 4.1. 0.1 times 4.1 is 0.41. 1 divided by 0.41 is going to be a little over 2. Think about it as I get closer and closer, it's going to be like 0.01, and then it's just going to keep going up and up. Now the part that I was saying as far as telling whether it goes to infinity or negative infinity is to just think about this now. Once I have this factored out, if I look at my denominator here, my numerator stays a 1. It's not going to change at all. If I'm coming from the right-hand side, it's all the numbers that are bigger than 2. So if I subtract 2, that's going to be a positive number. So this is 1 over a positive. And then if I do any number that's bigger than 2 plus 2, that's also going to be positive. So I have 1 over a positive times a positive, which tells you this is going to go to positive infinity. Looking at part B here, x approaches 2 from the left-hand side. So I'm still going to use this same model up here. If I'm approaching from the left side, it's obviously going to do the same thing as from the right. It's going to keep getting bigger and bigger, but we don't know whether it goes positive or negative. So think about it. 1.9 minus 2 would give me a negative number. So I would have 1 over a negative. And then 1.9 plus 2 is going to be a positive number. So it's 1 over a negative times a positive. That means this is going to go to negative infinity, because a negative times a positive is negative. All right, what about as it approaches x, or x approaches negative 2 from the right-hand side? If it approaches negative 2 from the right-hand side, that's going to be negative 2 minus 2. No, we can't just plug negative 2 in, unfortunately. It'd be like negative 2.1 minus 2. That would be negative 4.1. And then negative 2.1 plus 2. That would be negative 0.1. I have a negative times a negative. This is going to be going to a positive infinity. Look at it from the left. I can't just assume it's going to go to a negative infinity because I want to. So think about this as negative 1.9 if I'm coming from, or negative, what did I do last one? I did 2.1 in the last one, right? Negative 2.1. I should have done negative 1.9. Because this would be negative 2.1 is to the left of negative 2. So I should have done negative 1.9. That's my bad. Coming from the right-hand side, negative 1.9 is to the right of negative 2. So this would be negative 1.9 minus 2. That gives me a negative number. And then negative 1.9 plus 2 gives me a positive number. Negative times a positive is going to be negative. So coming from the right, it goes to negative infinity. Coming from the left, it goes to positive infinity. '19, we're going to look at it. It's kind of the same way. As x approaches 0, if I look at this, now I have two parts to this, so I'm going to break this up into two separate limits. Limit as x approaches 0 from the right, just so I can see it better. I don't have to do this. Minus the limit as x approaches 0 from the right of 1 over x. As x gets closer and closer to 0, this is going to get closer and closer to 0. 0 divided by 2 is just 0. So as long as this is 0, I don't have to think about this. Here, as it approaches 0 from the right, it's going to be 1 over a positive number. And that number is going to be getting increasingly closer to 0. And so I would think that this is a positive because it's 1 over a positive, but don't forget about your negative out in front here. That switches it and makes it a negative infinity. As x approaches 0 from the left, that would be all the negative numbers. And so it's going to be negative of a negative, which gives us positive infinity. For part C, it's a little more complicated because it's not just 0. It's approaching the cube root of 2. So if I think about the cube root of 2, the first thing I want to do is write that as a rational exponent. In other words, instead of the cube root of 2, that's 2 to the 1/3. Now, if it's 2 to the 1/3, if I plug that into this question, I'm going to square that over 2 minus 1 over 2 to the 1/3. Two to the 2/3 is what this first part would become. 2 to the 2/3 over 2. And we're still going to leave that as minus 1 over 2 to the 1/3. 2 to the 2/3 over 2. That's like 2 to the 3/3 because it's 2 to the first power. 3 over 3 is 1. That's going to give me 1 over 2 to the 1/3. If you remember how to do this, it's going to be subtracting them, 2 to the 2/3, and then it's going to be minus 3/3. That gives me 2 to the negative 1/3. And I can leave it like that, or I can make it 2 over 1/3. I messed that up. 1 over 2 to the 1/3. And then minus 1 over 2 to the 1/3. If I have the 1/3 in the denominator, it's the same as 2 to the negative 1/3. So now I have this minus this. It's the same thing being subtracted. My limit is 0. Part D, I'm looking for as it approaches negative 1. Think about plugging a negative 1 in. Negative 1 squared is 1 over 2. And then that's minus 1 over negative 1. So really that turns into a plus. So it's 1/2 plus 1, which would be 3/2. So you can't just assume for these ones that it's going to go to infinity or negative infinity. Some of them you're going to actually be able to find a limit for. Part C was 0, part D was 3/2. Okay, this was another problem on our quiz. Anytime we had a rational one, we should be looking to accomplish something before we try to take the limit. A lot of you just plug the limit in here, or plug the number into the limit, so you ended up with 0 minus 0 and undefined. You're not allowed to just do that. We have rules for rational functions. It says you divide by the highest exponent. So x squared divided by x to the third becomes 1 over x. Now the other thing I would do here, before I try to do that, is I'm going to see if I can factor this out as well. So x squared minus 3x plus 2, I want to factor that out because it's going to simplify. If we can make it simplify, it'll make it a lot easier on us. We could still divide by the x to the third for each term, but that can make it a little more complicated because we have to find the limit of 5 terms that way. Find the limit of this, minus the limit of this, minus the limit of that, minus the limit of that. It's a pain. So try to factor it out first. It multiplies to give me 2 and adds to negative 3. That's going to have to be negative 2 and negative 1. In the denominator, I can pull an x squared out of both of those, which leaves me x minus 2. That's nice because those cancel. Now I'm just looking at x minus 1 over x squared. Now I can divide each term by my highest power exponent. X over x squared gives me 1 over x minus 1 over x squared all over 1. So this is what we have to take the limit of. Now the limit is x approaches 0 from the right of 1 over x minus 1 over x squared. Now when I look at this, if I'm approaching from the right, what that's going to do is it's going to make it so that this is a number that gets increasingly larger. So this is going to go to infinity. And so is this one. And as I look at this, this one's going to infinity as well, but it's getting there faster because it's 1 over x squared. So it kind of complicates this procedure here. This one's getting there faster. It's going to mean that my limit goes to negative infinity because no matter what this number is here, as I get closer to 0, this one is always going to be bigger than that. Think about if I was to plug 0.5 in. 1 over 0.5 is the same as 2. This would be 1 over 0.5 squared. That would be 1 over 0.25. So this would be 4. Now I'm doing 2 minus 4. That becomes a negative number. So it's pushing this to negative infinity. I could have also stop at this point right here. Oh no. Let me finish this up. Instead of canceling, and look at what would be happening here. If it's approaching 0 from the right, a number close to 0 minus 2 is going to be a negative. A number close to 0 minus 1 is going to be a negative. Down here, a number close to 0 is a positive, and a number close to 0 minus 2 is going to be a negative. Negative times a negative, that's a positive on top. On the bottom, I have a positive times a negative. That is going to be a negative. Positive over a negative tells me it goes to negative infinity. So this can be a little tough to decipher, but ultimately they're not all that bad. I shouldn't have erased all that. So I still want to leave it in my factored form to do the rest of these. Part B, x approaches 2 from the right. We already know that this is going to be going to infinite levels at 0. But what about at 2? So if I do 2 minus 2, 2.1 minus 2, say, then that's going to be a positive. This is going to be a positive. Down here, this is going to be a positive, and this is going to be a positive. So I know it's going to be going to a positive. But just because it worked going to infinity at 0 does not mean it's necessarily going to work at the point 2. Think about your graph. I can have a line like this, right? I can have a graph that's going up to infinity here. But if 2 is here, this doesn't look like infinity to me. So this is where solving this out is going to work a little better. Cancel those. I have x minus 1 over x squared. Now I can plug my 2 in because it's not going to get rid of it. 2 minus 1 is 1 over 2 squared. That gives me 1/4. If I'm looking at it from the left-hand side, it would be the same thing. It's just going to be 1/4. Since it's the same from the left and from the right, our limit exists right there. It's going to be 1/4. Then it says at this point, what if anything can be said about the limit as x approaches 0? We don't know anything from the left-hand side, but if I was to graph this, I would see that there really is nothing on the left-hand side, and so it's going to be going to negative infinity. All right, I want to skip to one of the other ones, like this, where I have x plus 3 over to x plus 2. So this is where we're going to have to do our long division, like we did a couple days ago, looking at rational functions. So these questions are going to be like this. It will tell you that you are to graph the rational functions, including the graphs and equations of the asymptotes and dominant terms. So, whenever you're doing this, I don't necessarily need to see the graph, but I need to see the equations that you come up with. Or you have to at least tell me what your asymptotes are. So first we're going to have to do the long division. X plus 2 going into x plus 3. How many times does x go into x? It goes in one time. 1 times x is x. You're subtracting, so flip the sign. 1 times 2 is 2. Subtracting, so flip the sign. Those cancel. 3 minus 2 is 1. Now x can't go into 1, so that tells us that we have a remainder of 1 over x plus 2. Now whenever we have this, what is that actually telling us? Well, that tells us that we have a horizontal asymptote at y equals 1, which is this actual equation, or what we got when we solved that wasn't the remainder. So we're going to have a horizontal asymptote at y equals 1. And then we need to see if there's a vertical asymptote. Whenever we look at the vertical asymptote here, it's going to be whatever is undefined. So whatever we're dividing by in our remainder here, x plus 2, set that equal to 0. X plus 2 equals 0. Subtract the 2 over x equals negative 2. That's our vertical asymptote. I don't know why I wrote that. And so those are asymptotes that go into this one. For the next example, we have x squared plus 1 over x minus 1. I want to solve that one. Using the same method, we're going to do long division. X minus 1 over x squared plus 1. How many times does x go into x squared? If I multiply by an x, that gives me x squared. X times x is x squared. You're subtracting, you take it away. X times negative 1 is negative 1x. You're subtracting negative 1, so you add x. Now, I don't know how much you remember from Algebra 2 when you did polynomial division, but it is important to make sure that you don't do something stupid. These cancel out. It's not even what I was trying to do, but it's true. These cancel out. They erase each other. If I do 1 plus x, that doesn't work. Make sure you leave a placeholder in anytime. My goodness. Anytime you're skipping a turn. So you can leave a placeholder in that would be 0x to make sure that you don't add that. Try to add the 1 and the x together and call that 2x. But this is just x plus 1. Bring down that 1. If you can see it without adding the placeholder in, that's fine, but make sure that you don't make a careless mistake. I can't add 1 plus x, so I'll leave it as x plus 1. Now, how many times does x go into x? I would multiply by a 1 to get that. 1 times x is x. Subtract that. 1 times negative 1 is -1. You're subtracting a -1. It turns positive. X minus x is 0. 1 plus 1 is 2. Now x can't go into 2, so I leave this as 2 over x minus 1. Because I actually end up with an equation here that tells me it's an oblique asymptote, so you have to write that out. Oblique in the equation of the line is y equals x plus 1. Then my remainder tells me also that there's a vertical asymptote, and I need to figure out where that is. And so I take the denominator and solve it. X minus 1 equals 0. Add the 1 over. X equals 1. That's where my vertical asymptote is. Questions? Problems?